This is 6.2 right triangle trigonometry. So a lot of this should seem familiar, but you may have to pause the video and make sure you know those definitions. So you have a right triangle, and you have the angle theta right here. And so opposite of that angle is here, opposite, and then the adjacent, the side that's next to it, and the long diagonal side is called the hypotenuse. So the definitions of the trig functions, the 6 trig functions that we're going to be concerned about: sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and then tangent is opposite over adjacent. So these 3 right here are the primary trig functions. Make sure you know those 3. And a lot of people use SOHCAHTOA as the like the letter association. Like sine is opposite over hypotenuse, so this is sine. This is cosine, is adjacent over hypotenuse, and then tangent is opposite over adjacent. So SOHCAHTOA can help you remember those. Now, the other 3 trig functions are the reciprocals of those first 3 functions. So here, this is cosecant. Notice it's the reciprocal, so 1 over sine, and then secant is 1 over cosine, and cotangent is the reciprocal of tangent, 1 over tangent. So make sure you're familiar with all 6 trig functions. So if it says find all 6 trig functions, and I want the exact values, I want to be clear on that. I'm more interested in knowing the exact values of the trig functions. So what we're trying to find is sine, cosine, tangent, and then cosecant, secant, and cotangent. All right, now first what we need to do is find all sides. Notice we only know the legs of the triangle, so we need to use Pythagorean theorem. And we don't know the C. The C is always the hypotenuse, always the hypotenuse. I don't care which side is A, which side is B, that does not make a difference, but you're going to do 3 squared plus 4 squared, 9 plus 16. And normally when you take the square root of both sides, you write plus or minus, but we know that the distance cannot be negative, so we know that the distance of the hypotenuse is 5. So now we can find a 6 trig function. Remember, sine is opposite over hypotenuse and of theta. So here's theta, so opposite. This is your opposite side. So this would be 4 over 5. Cosine is adjacent, the one next to it, so adjacent over hypotenuse, so that would be 3 over 5. Tangent, opposite over adjacent, 3. Now once you have those 3 trig functions, the other 3 are just the reciprocals. So this would be 5/4, this would be 5/3, and this would be 3/4. And that's finding all 6 trig functions. All right, so common triangles. Now, again, pause the video if you need to, but 30, 60, 90 triangle, this first one right here, is a very common triangle that will happen a lot. It happens a lot in construction, same with the 45, 45, 90. These happen all the time in real life. They're very common, so make sure you know these. Now, you can sit or memorize them if you want, or just draw a 30, 60, 90. Know the relationship. So the way I do it, I know, the 30-degree angle opens up to 1, and the 60 opens up to the square root of 3. Now, the square root of 3 is actually bigger than 1. So when you evaluate the square root of 3, it's actually like 1.73, I think, or something like that. So I know this one's bigger than 1, so the 60-degree angle has to be the square root of 3, okay? And then the hypotenuse is always the longest. So 1, 2, square root of 3. Those are the measurements. Now, as long as you label the triangle and you know SOHCAHTOA, then you can find sine of 30 degrees. Again, you can memorize the facts. Sine of 30 is 1/2. Sine of 30 is square root of 3 over 2. Sine of tangent is square root of 3 over 3. You can memorize those if you want, I think it's a lot easier just to memorize the common 30, 60, 90 triangle because you already know SOHCAHTOA. If you know SOHCAHTOA and you know this 30, 60, 90 triangle, then you can find out the sine of 30, the sine of 60, cosine of 30, cosine of 60, tangent of 30, tangent of 60. You can find all those. Likewise, on a 45, 45. So 45, 45, again, these are the same angles, so the sides are going to be the same. And the square root of 2 is actually a little bit bigger. Remember, the square root of 2 is approximately like 1.41, I think, 41. And so I know the hypotenuse is the longest side. So 1, 1 square root of 2. And again, as long as you know this 1, 1 square root of 2, then you can find sine, cosine, and tangent of 45. Or you can just memorize it. If you have a good memory, you remember things well, you can just remember the sine of 45, the cosine of 45, the tangent of 45. Actually, these three are pretty easy to memorize, but I would rather memorize the triangle. The triangles are going to come in very handy. So if we wanted to, let's look at a problem and actually apply it. So if we graph the point -3, 1 and find all 6 trig functions. So like here's a piece of graph paper right here, and I graph the point -3, 1. And if you draw a triangle, your reference triangle, okay, your reference angle, which makes the triangle. So notice I have a triangle that is, this side here is -3, because I went over -3 and then I went up 1. And then you can use the Pythagorean theorem, so I know I have a triangle like this. And then from there, you can do SOHCAHTOA, all right, to find sine, cosine, and tangent. So again, we're trying to find of the reference angle right here. There's your theta. So sine is opposite over hypotenuse, which is 1 over the square root of 10, which, by the way, you can't leave square roots on the bottom, so this is going to be square root of 10 over 10. Again, if you need help knowing how to simplify that, pause that and ask, or look it up or something like that, but that's how you simplify it, because you can't have square roots on the bottom. So cosine is adjacent over hypotenuse. So adjacent would be of theta. So this would be -3 over square root of 10. And again, you can't leave a square root on the bottom. So this is going to be -3 square root of 10 over 10. Tangent is opposite over adjacent. So this would be -1/3. And then the reciprocals of those, so cosecant, secant, and cotangent are just the reciprocals. So if I take the reciprocal, this would just be square root of 10 over 1, or just square root of 10. Notice I actually looked at this step and I flipped it. The secant, I'm just going to flip the cosine, so that would be negative square root of 10 over 3. And this would be -3 over 1, or just -3. Okay, so I found all 6 trig functions, and that's right triangle. This is the first part of 6.2, finding right triangles. Make sure you watch the second part, part B.